Hello everyone. So for today presentation, this is part 2 of my project where I try to use the RPi0-2W and the OpenCM904 together. So today we'll discuss how to use the Pi camera with the RPi0-2W. We'll describe the dynamic source control scheme that I use, how I set up the OpenCM904 and the RPi0-2W, and then some general programming aspect of the robot with A4-WP-H. So here we go again. So I will show some specific bi-camera issue to use with the RPi0-2W that I need to share with. I will show the independent dynamic source network communication scheme that I'm going to use, the hardware configuration of both of them, power and communication and control, and then some of the programming aspect, and then a demo video at the end. So in the previous part 1, I already showed how that I use this website to install the RPi0, to install the Buster 64-bit to the RPi0-2W, and it worked fine. And when I was working on this project, I was start working about the second week of November until about now, which is December 3rd now. And for a while, this is about just before, before and after Thanksgiving. And although I keep on trying to update and upgrade every single day, the problem is I cannot see the Pi camera when I hook things up. There's no /dave.video0 anywhere. So not shown here, but I read, and then I had to use sudo RPi update to get the latest kernel in order to see the VIDEOO device. But luckily, if you haven't got your RPi0-2W yet anyway, starting in December, December 1st or December 2nd, which is basically a few days ago, when you do APD update and upgrade, you're going to get this one. And notice, so it's dated November 18 version, and it's still 51063, but a full build 1488. Now you have access to the Pi camera /DMESG. So the more you wait, the better it is, I guess. Alright, so once I have that, I started working with code blocks and stuff, and I found out that, oh yeah, I need to create a swap file about 384K, to have it compile it properly and smoothly. If not, it doesn't work. It just doesn't have enough memory, to run serious C programming code on it. So that means what? I had to watch wear and tear on my SD card because of the swap file. Okay. Another thing too is it didn't have to worry about it or it didn't appear in the RPi4B project that you've seen before on YouTube. But this time I have to use an HDMI display emulator here for VNC to work properly. If not, I think there is no, I think there is a composite display there, and it displays something, a very small display, so you cannot use the VNC viewer to work properly at all. Okay. And then for control communication scheme, the plan is to use two controllers, the RPi0-2W and also the OpenCM904. The OpenCM904 job is very simple. It can use task code. All it does is monitor DMESG to see if there is an obstacle or not. If there is, and then it had to figure out, okay, do I turn backward, turn left, turn right in order to evade it? And depending on those conditions or those, so we say, action that need to be made, it sends remote control packet via ZGB-SDK to the RPi0-2W. And you can use LNL1, BT410 dongle, or just plain USB cable for this connection. The RPi0-2W itself going to be using C++, use OpenCV to control the Pi camera. It control 12 XL430s, 8 are in goal position mode and time control, 4 in velocity control mode. So they're going to do all that via DXL SDK packets. via U2D2. So when you put in LN101 or BD410 and U2D2, both of them will be registered with some kind of TTY USB device. And the trick is, if you see an FT232RL, that's the chip that works for LN101 and BD410. The U2D2 is the FT232H. That's the only one. So in this particular case here, you can see that U2D2 is TTY USB 1 and LN101 is TTY USB 0. Power. So I use the good old Bioloy device here, which is the SM2S dynamic mode. So I loaded up with 12 volt. Now the SM2 dynamics module have two output of power. So I use one to power the OpenCM904 by itself. Basically, it has some DMESG sensor on it. That's about it. Didn't power much anything, and of course, the little task code residing on it. On the other output of the SM2S2 dynamic, so I used to power this new X3P hub. So it used the newer X3P pin cables. So this one have 5 of those, so it's just perfect numbers. So this hub will provide power and all the power line and also the data line to all the dynamics, so basically 12 of them. And it's kind of out of focus here, but the U2D2 is on the other side of the robot. So here top view, of course, RPi0-2W, you can see I can put in a FLIRC case, USB hub, of course, LN1 here, and then of course the HDMI emulator here, the camera usual place, and DMESG sensor up front, and U2D2 on the left side on top near the middle part of the robot. This is side view. I had to use whatever X3P cable that I have, so it's kind of a little bit longer than I need, but so it drags a little bit, but it's not bad. This is a picture of the A4W, the same robot, but when it was using RPi4B, is shown in my book. So CM50 in the bottom, and the RPi4B up here. So it has its own battery in 12 volt, 5 volt converter. So you can see a little bit more bulky when using the RPi4W. And it even have a little extension so that the little battery can sit on it. So it's a bit more bulky than the RPi0-2W version. So task solution, very simple. The task is monitored using callback routine to monitor the INR left and right, and then there is an algorithm that it runs through and if structures. So when there is no obstacle, it will send the remote control packet 0 to the RPi. When the obstacle is getting close and first detected, it will send a 1 to the RPi. And then depending on the situation, if it requires the robot to actually go back, it will send a 2 to the RPi. And if it needed to turn right, it will send a 4 to the RPi. And then of course you have, 3 and 5 for the other stuff. All right. And all this code is actually already provided in my recent robotics engineer book here. For the RPi0-2W solution for the robot itself, it's a mashup of the code that I already wrote for the A4W-H and the code I wrote for the for the spider. Already same thing discussed and documented in this book already. It's just a mashup of those two solutions, just modifying a little bit, coming here in and out several things. I plan to allow the new A4W-H to have 2 operating modes. One mode is remote control via the keyboard on the RPi0-2W. Okay, just regular manual remote control. But the OpenCM904 can override for the object avoidance feature. Second mode is autonomous color tracking, but you can also use manual remote control override. this mode here is completely performed by the RPi0-2W. Alright, so I create a solution, everything compiled okay, time to check runtime. And unfortunately, I found there's something wrong. There's some kind of runtime issue with the ZGB-SDK and RPi0-2W. I have tried all three type of connection, and the RPi0-2W OS reported and they find those devices, no problem. But the software just cannot connect. The first command was to connect to this port, basically connect the ZigBee, whatever, how it used to connect to these port, it doesn't work. The weird thing is, ZGB-SDK worked fine with RPi4B in all my previous project. You've probably seen all the other video I made, or if you happen to have my book, you read it, it's working okay. So I'm not sure if it happened with the most recent Buster update. I need to go back and check with my previous code with RPi4B in the previous project. And if it doesn't work now, that means a headache again. Okay, so therefore, I cannot implement the obstacle avoidance guidance from the OpenCM. So basically for this project, OpenCM is completely out of picture. So everything is really run, or the RPi0-2W really run the show in this project here. I didn't plan to do that, but that's how it turned out to be. So this could be interesting because some people already set their preference to me, hey, why do you care about any controller from Robotics? Is when you have the Pi, you just control directly and use T2. So you got your wish here. So it turned out to be that way here. Okay. So this is demo video, a short video. You see as usual here. So this bigger window here is of course the VNC viewer into the RPi0-2W that I have. So we have a code block here. The code is running already. It has some checking here to see if everything connected okay. So at the beginning of this video that I'm going to show you, I already extracted the color property of red ball, and the RPi0 already got it in the code. The OpenCV already got it. So when I start, all I do is push on T to hit the track, and you can see how it goes. And then so this is a 2-3 minutes video, I think, and then you see how it turned out. Okay, I made some comment as it run when I record this video. Okay, here we go. Point the robot is set and it's already recording. The red color is supposed to track. So all I have to do now is push T to see if it's working. Here we go. So once it's lost the ball, it just stopped. So let's give it another shot. Yeah, the camera, it pick up really too slowly to really work. Yeah, it's just too much. Here we go, try again. Yeah, the camera is not processing fast enough. Yeah, let's try again. Track. Oop. Now that's a robot failure there. Let's see. Reset. Okay, reset okay. Let's try to track again and see. At least backing way too close. Uh-oh, you lost it. Reset. You see, it takes a long time for the picture to show up. So I just stop it. So you can see, my conclusion so far is this. The RPi0-2W can handle 12 DXL and the Pi camera. You're using DXL SDK and OpenCV OK. Now in this particular project, the way I define the robot motion, amplitude and speed are just mismatched or too fast for the capability of the RPi0-2W to do image processing in OpenCV right now. So that's kind of the issue. So if you happen to have like a small wheel robot, RPi0 can probably work it. Or maybe you have an arm and you move it slowly, not like this robot, it probably would do it.